Right, hello everybody, and welcome to the end of the 21-day boot camp. Now, I know technically the last day is tomorrow, but everything that you have to do in terms of questions, answers, and things, and tutorial videos, you've had all of the course material now. So really well done if you have been able to keep up with that, if you've been able to actually look at the answers on the days they've come out, then that's a fantastic job in itself. And certainly don't worry if you've been getting some of it wrong, because that's the whole point. The whole point was to challenge you, was to stretch you, and you learn a lot more by doing questions that you find hard and getting them wrong within reason, within your challenge zone. Obviously, we don't want to get you to panic, but I'm hoping that you've found it challenging and that you've also found it really, really useful. So we've been looking at organic chemistry this week, and I've had a few questions about redox and about mechanisms that I was just going to go over with you. So one of the things that I got asked was about redox and about why we use dichromate as an oxidizing agent, and is it only dichromate? Like, is that the only thing that oxidizes an alcohol? Because we don't seem to hear anything about other substances. Actually, you have. So if you have done tests for aldehydes, you will have used Tollens reagent, which contains silver ions, Ag+. And silver ions are oxidizing agents. So in the test, when they react with aldehydes, what they do is they are reduced from Ag+ to Ag. So they lose an electron, they gain an electron to go from Ag+ to Ag. So therefore they are reduced and they therefore behave as an oxidizing agent. Now, silver ions are not as good an oxidizing agent as dichromate, which is why only aldehydes react with Tollens reagent to get that lovely silver mirror test, and why you can then use it to distinguish between alcohols and and aldehydes. And actually, that's generally the case, is that dichromate is one of the most powerful oxidizing agents, and that's one of the reasons we use it. There are some other examples of oxidation in organic chemistry that you will probably come across, and so one of those, for example, if you do an Excel, and I think possibly one of the other examples as well. Sorry, I zoomed in on this focus earlier and it's gone. That's better. Okay, so one of the things you might have found out is that you can add manganate, MnO4-. That's a very commonly used oxidizing agent for inorganic reactions such as iron 2 to iron 3. If you react that with an alkene such as ethene, this is a very specific reaction which results in a diol being formed. So you add OH groups across the double bond, but that is not really classified. It is an addition reaction, but it's actually also an oxidation reaction because we are forming two bonds with oxygen there, and so the carbon in that compound is being oxidized. That's quite a specific one, but you could be given it even if you're not studying it in your exam board and expected to recognize that that is oxidation. Another one that's used often in rates of reaction is weaker oxidizing agents. So one of the other questions I got was, can you get an alcohol, once you've got it to a carboxylic acid, can you oxidize it further? Because I used methanoic acid as my example, and I said that methanoic acid was the only one that could be oxidized all the way to CO2. So it's the only one that could lose these hydrogens. Everything else, if you have a carbon here, we said that oxidizing agents weren't really able to break carbon-carbon bonds because there's not really a mechanism that allows that to happen. So yeah, I did get a question, is there anything that can make methanol turn into carbon dioxide, or was that just something that I put in there to represent the oxidation numbers? And actually there is, and it doesn't have to be a particularly powerful oxidizing agent. So bromine, which links in really nicely with our stuff about redox as halogens as oxidizing agent, bromine is actually a powerful enough oxidizing agent to make that happen. So you make bromide ions, you make carbon dioxide, you're going to make water because you've got hydrogen coming off that compound. And so yeah, that means that chlorine could do it because chlorine is an even more powerful oxidizing agent, and I guess fluorine can do it as well. And the reason that bromine is the example that I've chosen is because you may come across that in rates of reaction. So that's a particularly good thing to monitor in reaction rates, because you've got this gas being given off, you've got an acid being used up, so you can measure gas volume, you can measure pH, and you've also got bromine, which is something that you could measure using the colour changes. So there are lots of ways to measure that, and it's a suitable one for reaction rates. So you may come across that in an investigation or something like that. While I've got the paper here and we're talking about organic chemistry, one of the other questions was about mechanisms. So you've done 3. You've done your free radical substitution, which wasn't really a curly arrow mechanism, but sometimes you have to do a few curly arrows in your initiation, propagation and termination. Then we've had our nucleophilic substitution, and we've had our electrophilic addition. So we've had 3, and there are 2 more to come: electrophilic substitution and nucleophilic addition, if you haven't done those already. But one of the questions was basically, well, will we be asked to do other mechanisms? Will we be asked to draw curly arrows or draw a mechanism for something that we've not seen before on the course? Because it certainly seems like in lots of other areas of the course you are asked to do things that are unfamiliar. And the answer is yes, you absolutely could. But you've just got to use the examples that you already know about to try and inform it. So for example, perhaps I've got some big, complicated, weird-looking molecule, and there is like a hydrogen on there, and there's a plus there. How am I going to resolve that? What would be the next thing that would happen in that, in terms of curly arrows? And it might be that you're given a clue. And so really what they're looking for is, well, I've got a plus on an oxygen, and the other thing that's weird about my oxygen is that I've got a kind of 3 bonds around it, which isn't normal for an oxygen. So my first thought would either be that the oxygen's going to lose the hydrogen, and so I would be drawing a curly arrow from the bond so that the electrons go back to where the positive is, so I'm getting rid of the positive charge. That was if it was to lose the hydrogen. If I've been told that the product contains OH, then the electrons need to come from somewhere else, and I can see that this bond has broken in the products, so I'd be thinking that these electrons are going into that positive charge there. So that's a mechanism we've never seen at A level, but I could work out the electrons have to come from a bond, there's no lone pairs on anything, and they have to go towards the positive charge. So it's not a real panicky situation. Other examples would be things with lone pairs attacking H+. That's something that happens all the time, so we shouldn't panic too much about seeing that in unfamiliar context. So yes, they can, but it won't be a lot, and there'll be lots of clues. So other questions about organic were, is it going to get much harder? And how is it going to get harder? Because most of the time at the moment, the difficulty is simply remembering all of the different functional groups, the different reactions, and the mechanisms of, hopefully, now that you've revised them, are not too challenging. So the mechanisms themselves won't get any more difficult. There's 2 more, but they're no harder than the ones you've already done. There will be more functional groups, so obviously there's more to remember, which is why it's so important to keep practicing and keep doing retrieval practice and keep putting that blank paper in front of you and drawing those reactions out. Not just flashcard flipping, not just looking at it and thinking you've got it, but actually trying to write that reaction from scratch. Like, not even with a question, but literally trying to remember what reactions you should know already, just to make it extra effort. The more effort your brain's making now, the easier it's going to find it in an exam situation. So how will organic get harder? As well as the more functional groups, you're likely to now start to get questions where a molecule has more than one functional group. So where a molecule might have a double bond and an alcohol group in a different part of the molecule, where a molecule might have a primary alcohol group in one place and a secondary alcohol somewhere else along the molecule. So that sort of thing is something to watch out for, and you will get practice as you go through. The other way that it's going to get a little bit more challenging is the questions will get a little bit longer and start to involve more spectroscopy, if you've done any of that yet, like mass spec, infrared, NMR, all of that stuff, and chemical tests. But the good thing about that is that you usually get a lot more information than you actually need. And if you sort of take a step back and look at all the pieces of information, it's usually the case that there's really only one answer, and that there are at least 2 or 3 things to confirm that one answer, which leads me excellently on to our last question about organic, which was really getting a bit confused about empirical and molecular formula in the context especially of organic questions. That's definitely going to come up, so you're going to get a lot of information about that. Oh, and that's perfect timing is that I've just seen somebody's asked a question about fragmentation, because there was a question about molecular ions as well. So let's just go back to the webcam, get a fresh bit of paper I think for this. So you're taking like a really, really big molecule. So the thing about empirical formulae versus molecular formulae is that the clue is in the word molecular means covalent. Because if I were to do an experiment where I were to work out the formula of empirical formula of an ionic compound, such as any of these guys at the top, NaCl, MgCO3, the empirical formula of an ionic compound, that's it. That's all you get. There's no such thing as a molecular formula, because lattice, lattice, lattice. So what we mean when we do the empirical formula is that there's 1 copper ion to 1 sulfate ion, and that's the ratio. Therefore, like, there's no sense in working out an empirical formula. However, if we were to look at a series of alkenes, so if I have my ethene and follow it up with propene and so on, I could keep doing it, and because of their general formula being CnH2n plus 2, I would have C2H4, C3H6, C4H8 would be my next one. Now, every single one of those has got an empirical formula of CH2, because that goes with the general formula. There's 2 hydrogens for every carbon in every single one of those compounds. So there is definitely a clear difference between the empirical and the molecular formula there. And there's a lot that we can tell from the empirical and molecular formula. So If, for example, one of the questions I gave you, I think the empirical formula was something with an odd number of hydrogens. That isn't a molecule. So that can't happen because of the number of bonds that carbon needs to make and the number of bonds that hydrogen makes. If you see an odd number, that is not the right formula. That's going to really help you next year when you have a really big molecule and it asks you to count and work out the molecular formula. So often there are questions where there's just a huge thing with lots of rings and it's a skeletal formula and you're asked to write it down. So that isn't a real formula of a real molecule, but I could have C6H14. That would work absolutely fine, and that's the formula of hexane. So if you're doing an empirical formula, you see odd hydrogens. Only time you can have an odd hydrogen is if you replace the hydrogen with a halogen. So that, as an empirical formula, is fine because I've swapped in a hydrogen, and obviously I could keep doing that, C3H6Cl2 and so on. So that works if there's oxygen as well. If there's oxygen, there still needs to be an even number of hydrogens for it to be a valid molecular formula. Okay, you can have quite a small number of hydrogens if you get a lot of double bonds, and if you've done benzene, you'll know that has a lot of double bonds. But at the end of the day, even if it's got oxygen and even if it's got lots of double bonds, even numbers of hydrogen. So that's one thing that an empirical formula can tell me, or that a molecular formula can tell me. I can also tell how many double bonds there are in a formula, or whether there's a ring present. So what do I mean by that? Well, we know our general formula, and I am going to get to the fragmentation, don't panic. General formula for an alkane is our CnH2n plus 2. And our general formula for an alkene with one double bond is CnH2n. But one of the examples I gave you was a diene. So, for example, we had something like that's penta 1,3 diene. So I could work out the formula of that by adding up all the hydrogens, and I could sit there trying to add, and this is what a lot of students do, adding on to the skeletal formula, working out how much it is. Or I could just go, do you know what, there's 1, 2, 3, 4, 5 carbons. Maximum number of hydrogens you can have with 5 is 14. 12, my bad. That's Friday afternoon maths. 2 times 5 is 10 plus 2 is 12. So if it was an alkane, it would be C5H12. If it was an alkene, I'd take 2 hydrogens off because I'm making a double bond, so I'm taking 1 atom off each side. If it's got 2 double bonds, I'm going to take 4 hydrogens off. So it's going to be CnH2n minus 2. So it's going to be C5H8 would be the formula of that. So I could work that out. That's also true if your molecule has oxygen present in it. So say, for example, you had a formula that was C6H10O. And you could get this sort of thing where you work this out as an empirical formula and you find out it's the molecular formula through something like mass spec. And then you would need to know something about functional groups, and maybe you'd be given some information about tests or other information like mass spectrometry. So, but the thing that I can tell immediately from the formula, because most people then tend to jump straight into the next piece of information, is that for 6 carbons, I've got 10 hydrogens. Now, if it was an alkane, 6 carbons would give me 14 hydrogens. 2 lots of 6, 12, that's 2. I've got 4 less hydrogens. So that tells me I've got 2 double bonds. Or it tells me something else, because the other way that you can remove hydrogen is if you had a ring where the carbons would join together. So anytime you're joining carbons together again, either in a double bond or where you're taking a hydrogen off the end, you'd have to take one off the end of each to join them together to make a ring. That, for example, would have the formula C6H12. That would be cyclohexane. The double bonds don't have to be carbon-carbon double bonds. So I could either have two double bonds. I could either have two lots of CC in my molecule, or I could have a carbon-carbon double bond and a carbon-oxygen double bond. Or I could have a ring and a carbon-carbon double bond, or I could have a ring and a carbon-oxygen double bond. Now, it's unlikely you'd get all of these options, by the way. It's very likely that you'd be told something useful, like, you know, it's got a ketone group or something like that you could get from the infrared if you've done infrared yet. And so, but what that means is just don't jump all the way straight to from the molecular formula and then start guessing at things. Definitely look to see whether there are double bonds or rings present in your molecule, and you can do that just by looking at the ratio of carbons to hydrogen. If you start seeing a really, really small number of hydrogens, it's probably benzene, but you may not have done benzene yet, so I'm not going to talk about it too much. So let's talk about fragmentation and mass spec just briefly. You will do a lot more practice of this as you learn more spectroscopy techniques, but let's just say, for example, that you had something very, very simple, C5H, I'm just going to go for an alkane. I keep doing 14, C5H12. So C5H12 has got 3 different isomers. Pentane, methylbutane, I'm not drawing the hydrogens, we haven't got all night, and dimethyl propane. So there's my 3 different possible isomers, and then chemically there's nothing different about them. Boiling point wise they would have different boiling points, we talked about that last week, but other than that there's no chemical test I can do for isomers like that, so mass spec would be where I would find information about that. So the key to mass spec is that you don't necessarily need all the pieces of information that you get. So I'm doing this in my head now, but I'm pretty sure that the molecular mass of that is 70. No, 72. So I'd go 512 is 60, 72. So that's the mass of the whole thing. And that would be my molecular ion peak. And what we mean by that is everything that goes through a mass spec has a charge on it. I'm not going to talk about how a mass spec works because it's different depending on different syllabuses as to whether you do time of flight mass spec or as to whether you do the great big magnet or as to whether you just actually don't learn how a mass spec works. It's actually one of the few things that's very different across the 3 exam boards. But all the things that are in common with a mass spec is that the thing that goes through has a charge on it, and so that's what we call it. It has a charge, it gets bombarded with electrons to get that charge, and it means that, just labelling that because it's annoying me not having a labelled y-axis, even though you can't read it, just says intensity. So just a relative scale, the height of the peaks tells you very little at all in fragmentation. So the height of the peaks for an element like chlorine tells you about the abundance of isotopes. That's really useful. That's not really useful here because it's all carbon and hydrogen. They've got very few commonly occurring isotopes. You may have heard about the M+1 peak down here due to carbon-13. That's not going to be very big at all for an isomer of C5H12. The more carbons you have, the bigger that peak gets because the more chance one of the carbons will be carbon-13. It's about 1% prevalence. So I can tell the most useful information is the actual mass of the whole molecule, but if I was trying to tell the difference between these isomers, I'd basically look at what can form in the mass spec. So I can cut these molecules in different places, and many of them are going to have the same peaks. So many of them, for example, are going to lose CH3. They can all lose a methyl group. That's not overly useful. And I've just put my calculator away, so now I'm going to be doing this in my head. But one peak you'd expect to see in all of their mass specs would be a peak at a mass of 72 take away 15. And that's because 15 is the mass of that. 1 carbon, 3 hydrogens. So, tiny bit of mental maths. Oh my goodness, 70 minus 15 is 55, so 57. So there would be a peak at 57, and it would probably be quite big. It's quite a high probability of losing a methyl group because loads of them have got methyl groups in it. So that height really just tells you like how likely it is to form that positive ion. It doesn't tell you much more about it. And it may be possible that I could lose both of them could lose another methyl group, but that's unlikely because I'd be chopping off 2 bonds at the same time. So most fragments don't form like that. Most fragments will be just breaking 1 bond. You'll also get a big old peak at 15 because sometimes it's the fragment that weighs 57 that goes through, and sometimes it's the fragment that weighs 15 that goes through. So could I tell, this is the worrying bit, is I think, can I actually tell the difference between these isomers using mass spec? I think that I can, because with the bottom isomer, no, not with that one, no, this one. With the one up here, I could lose both of those methyl groups and I would get a mass of C with C3 and then 1, 2, 3, 4, 5, 6, H6. So I could get a fragment that has a mass corresponding to C3H6 from this one in the middle. I can't get that with the top one. So if I cut the top one, then this is going to be C3H7. It's really unlikely that we lose hydrogen atoms in this process. It's usually the carbon-carbon bonds that break. And then I could get C3H6 out of the one at the bottom. So is there anything else that I could get out? Well, yes, there is. So I'm just going to draw that isomer again because it's got really, really messy. But with methyl butane, I can also make a C3H7. So if I cut, oops, I'm not in the chart. If I cut here, then this would be C2H5, and this bit here would be C3H7. So that's both of the straight chain and the methyl butane can make that. So it's really just trying to work out whether you can make the same fragments or not. I've chosen a really poor example, actually, I do apologise. But the fragmentation is just working out whether you can get particular combinations of atoms together or not from the original formula. So in a mass spectrometer, there should be no breaking up and sticking back together again. You can occasionally get molecules that hydrogen bond to each other, and then you'll get a mass that's bigger than molecular ion peak. We talked about that with aluminium chloride, actually, that it bonded datively, and then you got something that was bigger than the molecular ion peak. One thing to notice is when you're trying to work it out, if you've got a really big number, don't sit there trying to add up carbons and hydrogens to make 57. See how you get from 72 to 57. So see what's taken away. When you've got small numbers at the other end of the mass spec, count up how many atoms you can work out and see whether you've got that in the original molecule. Have you got them in that order? Where it would be more useful is where you've got more complicated isomers, such as esters. Yeah, there we go. So both of these are isomers of each other. They both have 6 hydrogens, 3 carbons, and 2 oxygens. But if, for example, I cut the molecule here, I can make a formula with 1C, 1O, and 1H. And I just can't do that anywhere here. There's no combination of a C and an O and an H. So I would expect 12 plus 16, 28, there to be a mass of 29 in that molecule. Also in this molecule, there is a bit here, which is C2H5, which, I did not do this on purpose, also has a mass of 29. And so that's not present in this molecule. If I add this oxygen in here, add on 16 to 29, and this is where I just go, what? Maths again. That would be 45. So this end has a mass of 45. This molecule doesn't have any way of bringing together 2 carbons, 5 hydrogens and an oxygen, because the carbons are like, the hydrogens are at each end of the molecule. So you can't fragment it. This one would make peaks at 29 and peaks at 45, and this one would not. So usually mass spec is just used at the end of a question, just to validate what you already know. So you'd already know stuff like infrared, you'd already know what bonds were present, and you'd probably, by the point you got to mass spec, just have it down to 2 possible isomers. And so the main thing is to try and look for the differences as to how they'd look different in a mass spec. Okay, moving on from the sort of chemistry related questions more to the, oh, my mouse has gone to sleep, there we go, more to the exam related stuff and the stuff to do with revision and everything else, now that we're at the end of the course. So one of the questions, I know that some of you are actually in year 13 and you've actually done your A-level, or rather you haven't because they were cancelled, and you're not sure whether you should be preparing to retake or not. Now there's a lot of nasty, quite manipulative, deliberately clickbait headlines going on out there right now. There's an awful lot of people who work in an exam board or people who used to be the inspector of something else giving their opinions, and that's it, just opinions, about the grading process, about the likeliness of people needing to retake, about whether kids will get into university. Most of it can just be flat out ignored, okay, and stop worrying about it. So first thing to think of is that universities want students in September, okay? They're really going to need students in September. They're going to be very down on international students. So if you're thinking, should I be retaking? The likelihood is no. So 2 reasons for that. One is your teacher will probably have given you a pretty decent grade. There's a lot of talk around about schools bringing them down, about the exam board bringing them down and saying that schools have overdone it. The exam boards are just going to bring them in line with what they normally are and what would normally be expected. So don't expect a huge bringing down of exam grades. Don't start losing sleep about that. It's not worth it. So the likelihood is, unless you know that you were last minuting and that you really did badly in a mock and throughout the year because you weren't taking it seriously, that's the case. Yes, you probably won't get the grade that you wanted, but actually at the end of the day, come on, you probably weren't going to get it anyway, because that's what happens. So should you be preparing for a retake right now? No, wait till August. You'll have plenty of time. Okay, so August results come out mid-August. They're coming out normal time. They're not coming out late. You'll have until October to retake if you need to. But my recommendation would be, especially if you're going for a competitive course, have a look and see what you can get into this year. I know Freshers Week might be rubbish. I know it's not what you perhaps maybe expected from your first year of university, but if you really want to go for something that's quite competitive, then go this year, definitely, because next year is going to be crazy with the people that have deferred and the people that have decided they don't want to go this year. So take advantage of that. If you were a little bit not sure, if you weren't sure whether you were going to get that A that you needed to get into medicine, and you get an offer for medicine this year, I wouldn't sniff at that. I wouldn't sit around trying to do it again just for the sake of it. So that's what I would say on the exam grades. There's time after August for year 13. You need a rest. It's been a pretty stressful time for you. It's already a time when you have so much changing in your life to be hit with this whole pandemic situation. You need time to process that and not just be spending your whole time worrying about a retake that probably doesn't need to happen. That's for my year 13s, okay? And the year 12s, obviously it's been a pretty crappy time for you too. You're thinking we've missed out. We didn't get to do our summer mocks. Most of you would have been doing mocks in the summer, which would have then prepared you for your UCAS and applications and everything else. And again, there's so many headlines going about, like this might happen and we might reduce the content and we might do this. At the moment, it seems the most likely that you will just possibly be doing your year 12, your A-level exams a little bit later in the year, which is rubbish. Nobody wants that. I don't want to invigilate them, thank you very much. But we've got to do what we have to do. So it looks like, to allow catch-up time, you will just get a bit longer next summer before the exams start. So there is plenty you can do. And I think rather than panicking about what you've missed, just use the time you've got, as well as taking a break, obviously. Summer holidays, you've got to have a break. Use the time you've got to just really solidify, which was part of the point of this course, the year 12 material. That's a really good use of your time, because you need that stuff in the front of your brain, and the better you know it, the quicker you'll learn the year 13 stuff. Okay, so the better you understand redox now, the quicker you'll understand redox in the second year. The better you know your calculations, the less stuck you'll get when you have to do like a redox titration calculation in the second year. So yeah, I wouldn't panic about pushing forwards and trying to teach yourself stuff. There's some good stuff out there. There's some stuff on my website that shows you like some good YouTube channels and things like that, but you don't need to worry too much. So yeah, I guess the last thing, there's two more things, which is about if you've enjoyed the course. Tomorrow, the last email you'll get from me will just be like a begging email, which will be, please could you like, share, all the usual online stuff. I'm quite new to the online thing. I'm not new to being online, obviously. I'm not a robot. I have a Facebook account. I'm quite new to putting my tutoring services and my business as an educational professional online. That's what I meant. And so I'm a bit like I haven't got any reviews or anything like that, even though I've been tutoring for 20 years, because people have just come to me and that's just been how it's going. But I'm going a little bit part-time next year, and I want to sort of expand my tutoring. So reviews from people on the course will be really, really nice. I've sent a link to the Google review thing, so the sort of Google business page. I've sent a Facebook link. I know a lot of you aren't on Facebook because it's not really a teenager thing, but your parents might be. So they could just like the page, share it, whatever. Also, just, what was the other thing? I've completely forgotten. I do have a Twitter account. I'm getting there. You see, it's all these things I'm just kind of edging forwards. Anything just to, if you know people that might be interested, just to share my website with them, stuff like that. That'd be helpful. And if you're interested in private tuition, I meant to send it out at the end of this, but got my timing wrong. So you've already got an email from me explaining about what I'm doing over the summer and what offers I'm offering. So I normally, obviously I'm a full-time teacher, but I'm going down to part-time in September, but I'm using my summer because I'm going down part-time, because I've got the time and I can't go anywhere. I normally do tons of Duke of Edinburgh and stuff like that. I really, would like to use it the best I can to help as many students as I can. So what I offer, normal one-to-one tuition, online obviously, and there's, I put in the email, there's a discount for people on the course, so you would get your first 4 hours of that, which is sometimes all people need anyway, at £30 an hour instead of 35. Doesn't seem like a huge reduction, and I know there are people out there charging 15, but they're uni students. They're not people that know the exam board as well as I do, and know how to teach it as well as I do. So that's just how it goes in terms of prices. That's why I charge that. I try, please don't email me and say, can you do it cheaper? Because I'm already trying to keep it as cheap as I can for what I do. What I find is students get through stuff quicker with me and more effectively because I know what I'm doing and can get them through it quicker, as opposed to just having somebody helping with your homework, which is a slightly different thing. That's one-to-one tuition, but actually I'm trying to get people to do it more effectively and get more for their money, which is why I'm offering study programs as well. So a study program is something where you sign up for 6 weeks, so you've got a commitment. You get assignments from me. So it's like the kind of course that we've just been doing, but the difference is the assignments are personalised to you, because I have a meeting with you at the start of the course to find out what it is you specifically want to work on, real areas that you need to go. I will know what course you're doing and how far into the course you are. So I will know all that about what topics you've already covered, which ones you want to go through, which bits of the exam you can't do, all of those things. And if you don't know, then that's all part of it as well, because then I just set you assignments and I work it out over the course of the course, what it is that sometimes you might think that you struggle in a particular area, but it's actually something completely different. So that's much more personalised, and the reason that I'm doing that is then basically what would happen during those 6 weeks, every week, not every day, not that full on, I will give you some assignments, and then when you get them back to me, you get me marking them and actually telling you exactly where you went wrong and exactly where you can improve. So it's much more specific to you rather than just me putting a video on YouTube and guessing where you went wrong. So it's much more efficient of your time. And then it means that when we included in those courses is either 2 or 4 or 8, depending how much you want, hours of private tuition as well, which means that when you've done the assignments, we can really quickly get down to the things that you need to work on, and we can use those 2 or 4 or 8 hours to the best advantage. So that's why I've got those courses, and they actually work out a bit too cheap. I actually worked it out in terms of my time, because it took more time than I thought to set some of the assignments and the marking and everything else, and I thought, okay, I may have done it a little cheap, but I'm leaving it out there, and I'm even giving people that were on the course a 5% discount on those as well, just because I said I was going to give a discount and I don't want to be lying. So it's only a small discount, I apologise, but they are already heavily discounted. And then the other thing that I'm doing, again, because I just kept thinking, what can I do for, students who can't afford £30 an hour? Like, that's, I know, because I've been there as a sort of, working class background, believe it or not. The accent is because I was brought up in RAF camps. But none of my family had been to uni, so the idea, I've never had anything in my life such as a private tutor. That's completely out of my mind. I think I had a piano teacher for 2 years, and that was a luxury. So I've never had anything like that in my family. So I know how many kids are out there that are just struggling on their own. So I'm also offering small groups. Suddenly thought, what a benefit of online is that I wouldn't have done that before, because the thought of trying to get like 4 students in one house at the same time to tutor them, or 4 students coming to my house, would have just been incredibly challenging. But there's nothing hard about getting 4 people on Zoom together. And so I just thought, wow, that's a real opportunity for people to share tuition time if they can't afford the hours themselves. So I'm offering that as well, up to 5. I think 5 is really the maximum to get the benefit out of it. But I think that's a really good way for people to share the cost and get some really useful experienced help. So if you wanted to do something in a group, it would only be £40 for the first hour, and that's regardless as to whether you have 2 people, 3 people, 4 people, or 5 people. So if you had 5 people and you were paying £40, you're each paying £8. So the cost of a coffee and a bagel, which you can't buy anymore because nowhere's open to sell them. I think they are now, but I'm avoiding them. So you can do that, and it's the discount. So it's normally £50 for an hour, which is still only £10 per person if you've got 5 people going, or even £25 each if you just want 2 people. It's just an easier way to share it. And the discount, the £40 bit, is whether you, doesn't matter how many people have been on the course. So if it's just one person has been on the course and they know 4 other people, you still get it for that cheaper price. I wouldn't expect that. One thing I will say about the groups, or 2 things, you have to find your own group. Okay, I'm sorry, I can't match you up with people. That would take hours to work out people that were doing the same course and wanted to know the same things, or like go over the same things. It's never going to happen. That would just, and also just for your own protection, that you're definitely in a group session with people that you know. I'm quite conscious anyway that this whole online tutoring opens up a few issues, like you're seeing the backs of people's houses and things like that. So that's why I say find your own group, and then you know that you're all doing the same course and that you've all got the same goals. And the other thing, again, admin related, would be that one person pays the fee. It would be split between you, but you sort that out yourself, because I can't be chasing like 3 or 4 payments just for 1 hour's work, because again, I would just have to add that into an extra fee because of the amount of time it would take. So that's all the different things I offer. Have a look at the email. I haven't really advertised this stuff yet. I've already got 5 students that I already had, and one of them has just signed up for one of the courses and wants 8 hours over the summer. So I'm already at a third to a half capacity. So what I'm hoping is I don't get absolutely inundated, so don't feel guilty if you're not after the online tuition. I'm hoping I'll just get a trickle in of interested people, and then I can help you all. But I would say that if you're not sure, I wouldn't sit on it too long, because I may get inundated, because lots of people have had a lot of time off school and they're a little bit worried about catching up. If I get too inundated, I will put people on waiting lists, but I will try and get as much as I can done over the summer, because as I said, I might as well, because I can't do any of my normal travels or hiking as much as I normally would like to do in the summer, and I can't really visit my family because most of them live abroad. So therefore I may as well make use of it and help people out. So don't be too slow on responding. I'm going away tomorrow for a whole week. I will be on my emails though, so I will be checking in on them. It's the only work I've allowed myself to do next week. And And so, yeah, if you don't hear from me within 48 hours, I'd give me a prod, because that seems like I've missed your email or something like that. That's about it. Likes, shares, reviews. If you want to take advantage of any of those deals, get on it quickly so you don't miss out. But that's about it, and I've really enjoyed doing the course most of the time. Oh, and evaluation. Got to have a good evaluation form after a course. That is in tomorrow's email too. So in the same time as spreading the love online, it will literally take about 5 minutes for you to just fill in, so that I know I might run this course again at the end of the summer. And so it would be really helpful to know which bits worked best and which bits didn't work best. You know, if there's things that I'm doing that are taking hours and actually I don't need to, then that's really, really useful to me. I've talked a lot longer than I meant to, especially for a Friday night. That's about it. I got no more questions coming up on that bar, and I will see you when I see you, either in a Zoom tuition session or another one of my shoddy YouTube videos, because I am going to make some for year 13 content, or elsewhere. So thanks for listening live. Thanks for listening to the recording if you're listening to the recording. See you soon.